Hello my dear students, welcome to ICS Mahesh PU College, Dharwad. In this session, we are learning a very important topic for theory as well as competitive is concerned, electrolysis. Here we are learning electrolysis of molten NaCl, aqueous NaCl and sulphuric acid, both dilute and concentrated sulphuric acid. Here it is very important for boards and competitive, the electrolysis of molten NaCl and aqueous NaCl. Myself Jairaj Agde, and let us get into the topic without any delay. In our earlier sessions, we have seen the electrochemical cells are divided into two types, electrolytic cells and electrochemical cells like voltaic or galvanic cell. See, in electrolytic cell, the example electrolysis of acidified water, in electrolytic cell which converts electrical energy into chemical energy, and the voltaic or galvanic cell which converts chemical energy into electrical energy. We have learned these things in our earlier sessions. Let us try to understand what is electrolytic cell. Electrolytic cell is an electrochemical cell in which a chemical reaction carried out by passing direct current through a solution. Here we pass DC current and we make a non-spontaneous reaction to happen, a reaction which will not get it by own. So we supply electricity, we supply energy in the form of electricity, and we make that to happen. This is called electrolytic cell. Here electrical energy is converted into chemical energy. And we have another type of cell called voltaic or galvanic cell. We have detailedly discussed in our earlier sessions. Here what exactly happens, it is also an electrochemical cell. Here spontaneous redox reactions which occur by their own by liberating energy, and we convert that liberated energy in the form of electricity. In this case we convert chemical energy into electrical energy. So that's why we call it as galvanic cell or voltaic cell. We have discussed, we have n number of galvanic or voltaic cells like Danielson, etc. We have learnt it. Let's go for electrolytic cell in particular. See, in an electrolytic cell, whatever the process occurs is called electrolysis. Here breaking or the decomposition of compound takes place by supplying electricity. Let us learn the electrolysis of molten NaCl. So we take a solution, which is not a solution, it's a sodium chloride which is in fused state or liquid state or molten state, which contains only Cl minus ion and Na plus ion. We immerse two graphite rods or platinum rods. These are called inert electrodes. We have these two, and these are connected to battery. The DC battery. What exactly happens whenever we supply the electricity, DC voltage, DC current, the electron starts move and it makes it as two electrodes as anode and cathode. Anode is what? Anode is the place where anion goes. So Cl minus go to anode and Na plus goes to cathode. As I have supplied electricity, what exactly happens? The electricity flows to cathode. So cathode, the electrons will move to cathode and makes this rod electron rich. Here Na plus takes these electrons and gets deposited as sodium. Here it deposits as sodium. So that's why here the reduction has to take place. Always reduction occurs at cathode. Na plus takes one electron and forms sodium metal. And what exactly happens here? Chlorine, it will become electron deficient. So that's why chlorine Cl minus chloride ion will give away its electron and forms chlorine gas. So here the oxidation takes place by liberating electrons. Here the reduction takes place by accepting electrons. That is the reason the chlorine gas starts bubbling from anode. The oxidation half reaction occurs at anode is Cl minus will give Cl2 plus electron, or 2Cl minus will gives Cl2 plus 2 electron. Here the oxidation takes place at anode and reduction takes place at cathode. Usually it will be asked whatever the gas liberated at anode, the gas which is liberated at anode when we take molten NaCl is chlorine, and the metal which is deposited at the cathode is sodium. Only when we have taken molten NaCl. The things are not same if we take different electrolytes. See, net cell reaction is Na plus plus 1 electron gives sodium, Cl minus gives 2 electron to form chlorine. Here 1 electron is accepting from Na plus ion. Here 2 electrons are liberating. In order to balance, I should have to multiply this by 2. That's why overall reaction will become 2 Na plus plus 2 Cl minus gives 2 Na plus chlorine gas. This is what the overall reaction is. The current always flows accompanied by chemical changes. Whenever a current flows through the circuit, it always do some chemical change to happen. Let us try to understand the electrolysis of aqueous NaCl or brine solution or sodium chloride solution. Here we don't have only Cl minus and Na plus, we also have OH minus and H plus present in the solution because we are carrying the reaction in water medium. Water medium also contains OH minus and H plus, and however we have Cl minus and Na plus in the solution. Now for oxidation and reduction, there occurs competition between Cl minus and OH minus and Na plus and H plus. Let us learn it. To our anode and cathode, if I take inert electrode like graphite electrode or platinum electrode, if we take mercury electrode, the things are different. If we take inert electrode like platinum or graphite electrode, what exactly happens? Here it is cathode and here it is anode. To cathode, cation will move. Na plus and H plus will both go to these cathode, and Cl minus and OH minus both move to anode. But what exactly happens then? But the one which is liberated will be H2 gas, because in between Na plus and H plus will preferably goes and gets gets reduced to form H2, and in between OH minus and Cl minus goes to anode and gets oxidized to form chlorine gas. So the species which is liberated at anode will be chlorine, the species which is liberated at cathode will be H2 gas. But why this has to happen? Let us understand this. Here H plus gets reduced and Cl minus gets oxidized. What is the reduction half cell? Reduction half cell reaction is 2H plus 2 electron gives H2. Similarly, oxidation half cell is 2Cl minus will gives Cl2 plus 2 electron. And NaOH will be the byproduct. Let us understand it bit detailedly. What is the reduction half reaction? See, in the reduction we have two species, H2 hydro H plus ion and Na plus ion. There will be competition between H plus and Na plus to undergo reduction. As we have seen, the reduction potential Na plus plus electron gives Na. It requires the reduction potential of sodium is minus 2.71, whereas the reduction potential of H2O to H plus, H2O to H2 or H plus to H2 will be very less. That is, we can consider it as 0 for H2O to H2, it is minus 8.3. See, we already know higher the reduction potential, higher the A's of undergoing reduction. reduction potential is more. If reduction potential is more, the chances of getting it reduced will be more. So if I compare to minus 8.3 and minus 2.71, minus 8.3 is larger than minus 2.71. So that's why the reduction potential of water is more than reduction potential of Na plus. Preferably water undergoes reduction. So instead of sodium, which happens in molten NaCl, here we get hydrogen gas. The reason is high tendency of undergoing reduction of water. Let us go for, hence the cathodic reaction is H2O to H2. Now let us go for oxidation half reaction. What exactly happens in oxidation half reaction? Here also we have two anions, Cl minus and H2O. In between Cl minus and OH minus, whichever undergoes reduction will lead to which product will liberate at anode. See, in this computation what exactly happens? 2 Cl minus to give Cl2 plus 2 electron and its reduction potential is 1.36. 2H2O gives O2 plus H plus plus 4 electron. E naught is 1.23 voltage. See, if we feel, yeah, wow, 1.36 is higher, that's why it should have to undergo reduction but not oxidation. Here we are talking about oxidation half cell. The one which has low reduction potential has more tendency to undergo oxidation. So that's why in between H2O and Cl2, the reduction potential of oxygen is lower. That's why oxidation potential should be higher. That is the reason E naught of oxidation potential is greater than E naught of chloride ion. What we feel? We feel that the tendency of H2O undergoing oxidation is more than tendency of Cl minus to undergo oxidation. That's why expected product at anode we should expect is O2, because preferably oxygen should have to liberate, because H2O preferably undergoes oxidation than chlorine, but it is not the actual situation. Instead of O2, Cl2 will be liberated. The gas which is liberating at anode is chlorine. The gas which liberates at cathode is hydrogen, and the gas which liberates at anode is chlorine. Why that had to happen? So this is exactly reverse to the electrochemical series. Why that had happened? This one is called overpotential. This phenomenon is called phenomenon of overpotential. Actually what happens? The chlorine, hydrogen, oxygen, whenever there is a liberation of gas, if the gas is liberating from the electrode, the reduction potential which is calculated will be different than the reduction potential which is actually required. The calculated value of SRP is different and the actual value of SRP is different for the electrodes where the gases are liberating out. Those extra potential which is required to make that gas to liberate is called over voltage or over potential. If I compare to oxygen and chlorine, over voltage of oxygen is more than over voltage of chlorine. So oxygen needs more current to undergo oxidation, but that is not the case with chlorine. So preferably which should have to come out? Chlorine. So that is the reason, because of its over voltage of oxygen is more than chlorine. Instead of oxygen, chlorine gets liberated. Instead of oxygen, chlorine gets liberated. Let us see the equations. NaCl gives Na plus and Cl minus. 2Cl minus gives Cl2 plus electron. This is the anodic half cell reaction, and the cathodic half cell reaction is H2O plus 2 electron gives H2O and 2OH minus. Therefore net reaction is 2NaCl plus 2H2O gives Cl2 plus H2 plus 2NaOH. Let us try to understand the electrolysis of sulfuric acid. H2SO4. We can have two possibilities, the dilute sulfuric acid as well as concentrated sulfuric acid. Let us see for dilute sulfuric acid. Dilute sulfuric acid contains what? H2O, H2 and O2, H2O, H plus, O2 and 4 electrons. So that's what happens actually. The reaction possible at cathode would be what? The H plus ion should undergo reduction to form H2 by liberating 2 electrons. Similarly, the anodic half cell reaction is water is undergoing oxidation to O2. So here hydrogen is undergoing reduction and oxygen is undergoing oxidation, but this happens in the presence of water medium. That's why the products are O2 and H2. But this is not the same case if I have taken concentrated sulfuric acid. However, the reduction reaction is same. 2H plus 2 electron will gives H2. This is the same reaction for both dilute and concentrated sulfuric acid, but that is not the same case with anode. If I have taken dilute sulfuric acid, then there will be competition between SO4 2- and OH-. Finally, OH- wins. Hydroxyl ion wins over sulfate ion. But that is not the same case with concentrated sulfuric acid, because there is no water present in concentrated sulfuric acid. That is the reason 2SO4 2-, sulfate ion undergoes reduction to form, sulfate ion undergoes oxidation to form S2OH 2-. Here sulfur's oxidation state is plus 6 only. There is no change in the oxidation state of sulfur. However, the oxygen has undergone oxidation. The oxygen in sulfate has undergone oxidation. That's for today. Thank you so much for watching and supporting. Please share, like and subscribe.